Okay, so the next section is on ketones. So if we have a look at ketones, ketones are similar to aldehydes, except ketones have a C double bond O group. That's it. There is no H, so it's just C double bond O. So how do we name ketones? Well, first of all, if you want to write a ketone, you're dealing with anone at the end. And when you're looking at ketones to name them, you naturally start with, let's say, the first carbon. So if we start with the first carbon ketone, you would be doing something like this, C double bond O. Now, if you do that, you would then have to make sure that each carbon has got 4 bonds around it. So you have a hydrogen there and a hydrogen there. And that would be your first ketone. And generally we would call this something like methanone. And then you would move on to the second ketone, and again you do the same thing, a C double bond O bonded to another carbon, and you would just make sure that all carbons have got 4 bonds around them. So again, this one here then would be called ethanone. But there's something there that I want you to look at. So if we go back to aldehydes that we had a look at in the previous question, or in the previous video, if we go up and look at the first 4 aldehydes, let's have a look. So I think I can copy all of these here. So if I draw around this, copy, should be able to paste that into ketones. Let's have a look. So here is the aldehydes. And something that you'll notice is that your methanone, which is here, and your methanal, which is here, these two things have exactly the same structure. So the same thing applies then for ethanol. If you look at ethanol here in blue, and you look at ethanol down here, these two things also have the same structure. A C double bond O with a H, and a C double bond O with a H, and a CH3 at the start, and a CH3 at the start. So these are exactly the same. Because of this, there is no methanone or ethanol. So methanone and ethanol don't exist, because when you draw them out, they're actually methanal and ethanol. So your very first ketone is not going to be meth or et, it's actually going to be prop. So let's get rid of all of this. I'll be back in a second. So how to construct a ketone then? So the first one we've got to look at is 3 carbons. So we're going to run 3 carbons across, and we've got to figure out where we're going to put the C double bond O. So the double bond O has got to go on one of these carbons. The problem is if we put the double bond O at the end, then this just becomes an aldehyde. So what we have to do is not put the double bond at the end. We have to put the double bond somewhere in the middle, and that's why they start on 3 carbons. So we put the double bond in the middle, and then we surround with hydrogens, and there's 4 already on this one. This one here is 3 carbons, so it's prop, and then the ending is anone. So this substance is called propanone, and you would write this as CH3, which again is this part here, your CO and your CH3. That's the way that's written. So CH3, CO, and then CH3. And that's how you distinguish between a ketone and an aldehyde. You can see the COs in the middle. Propanone also has another name of acetone. You might have seen that in the lab a couple of times, and one of the uses of that is nail varnish remover or whiteboard markers contain acetone. If you have a permanent marker and you want to get it off something, you can use some acetone to get rid of it. So that's the first one, propanone. The next one then you've got to do is butanone. So the same thing, 4 carbons, and then you have to pop the double bond O in the middle, surround everything else by hydrogens, and again this particular one here is but, and then anone. The formula then for that is going to be CH3, CO, and then the last group, rather than doing is going to be that. So that gives you C2H5. So that's propanone. Okay, so some uses. We need to put that in. So put in propanone as nail varnish remover. And then butanone, or both propanone and butanone. So propanone and butanone, both of those together, are used often in the chemical industry as solvents. So again, a solvent is just a substance that can dissolve other things. And we've seen that propanone or acetone can dissolve permanent marker. Let's have a look at the physical properties. So your physical properties, the first one then is going to be boiling point. So again, boiling point is higher than the corresponding alkane. So if you actually take the corresponding alkane, so the first one is propanone, so we're going to take propane. So propane, the corresponding alkane, this one here has got a boiling point of minus 42 degrees Celsius, whereas your propanone, oops, too many bonds in there, your propanone has got a boiling point of around 56 degrees Celsius. And again, you have to justify why that is. The reason for that is the carbonyl group. And again, I won't write it all out, but the C double bond O carbonyl group is polar. So because this is polar, it gives rise to dipole-dipole bonds. And when it gives rise to dipole-dipole bonds, in order to break these bonds, to boil it, to get it into a gas, you need a lot of energy. And this is what this is. This is really a measurement of how much energy you're actually going to need in order to break apart the molecules from each other. So that's boiling point. The second physical property that we always look at is going to be solubility. And we're looking at solubility again in two things. We're looking at solubility in water, and we're also looking at solubility in organic solvents. So organic solvents like methyl benzene and things like that. It doesn't matter what the organic solvent is, it still behaves the same way. So in water, ketones and aldehydes are very similar. So lower ketones starting at 3. So lower ketones are highly soluble in water. As you progress on and as the chain lengthens, so higher ketones are less soluble in water. And again, the reason for that is hydrogen bonding. There's hydrogen bonding in between the water and the ketones. And pretty much aldehydes and ketones, they have more or less the same formula. So they can often be isomers of each other. So they will also be soluble in organic solvents. So that pretty much ends the ketones. Again, just be very, very careful at the start that there is no methanone. And that's not to be confused with a word that you might have heard called methadone. Methadone is a different compound. It's not methanone. So there's no methanone and there's no ethanone. And that's important. Often comes up in the leave insert, that one. Okay, that's it. We'll move on to the next video where we'll talk about alcohols.